So Neil Langmead and Andre Maiden, Chantal Wouters here from Parasoft. I've just started the session, so people are still logging in. Andre, I'll give you the stage so you can immediately take over, and
Perfect.
I will be myself. I'll be here as a moderator in any case. Yeah.
Okay, so hello and welcome to joint webinar between Parasoft and Cone Clinic. My name is Andre Madan. So in this next slide, you can see our beautiful faces of your presenters today. I'm Andre Madan. I am Director of Solution Engineering at Parasoft. Prior to joining Parasoft about 10 years ago, I was a firmware developer and working on architecting approaches for testing safety critical applications at a medical device company. So I have an extensive experience in embedded testing, and I'd like to introduce my friend and colleague here, Neil. Neil?
Thanks, Andre. Yeah, my name is Neil Langmead. I have a background as a functional safety engineer and software tester. I love all things embedded and safety critical. So I help companies to get compliance to functional safety standards and deal with the topic of automation and accelerating safety critical application development, making it go faster, certifying components and making all that go at speed. I think that's the main topic today, and super excited to be here with you, Andre, talking about this important topic.
Yeah. So for all practical purposes, Neil, you have been actually boots on the ground in a lot of deployments, right? In automotive and medical and industrial controls markets, and you might talk about those experiences as well. But I would refer to you as an expert here on this topic.
That's kind.
Right.
No, a lot of testing work. Yeah.
You have been doing it. Parasoft is a tool provider and a tool vendor, and we're experts in what we do, and you're expert in what you do. And today, so today's topics, Neil and I are going to chat and show you snippets of tools and demonstrating practical approaches to get to speed when developing safety critical applications faster. So Neil, in your opinion, developing safety critical applications is a slow process. You need to worry about requirements and safety standards, right? Compliance, reviewing all of that, making sure that all the I's are dotted and T's are crossed. So in your opinion, you've seen that people wanted to go faster, right? What is the problem? Like, why would the safety and speed cannot coexist, or can it?
Yeah, people talk about the holy grail of speed and quality and value or price, and people say you have to choose two of those things. You can't have all three. But what I've discovered, and people associate speed with danger. You know, high speed means that you're careless.
I have a little slide for that.
Yeah, exactly. But you know, our research has shown that actually, if you bring in automation and you bring in the right tooling and the right processes behind those tools, that you can actually go very fast in compliance. And it's just such a bottleneck historically, functional safety compliance. When you have to take care of tests, you have to take care of requirements, topics like traceability, getting high levels of coverage, all of these activities that you need to perform for the functional safety standards are very time consuming and effort, require large amounts of effort. So putting that those compliance activities onto autopilot has been a major focus of our work in the last few years, and our partnership between Matix and Parasoft really accelerates that. And what we were excited to show the results of that research.
Yeah, so let's start discussing. So I'd like to understand if functional safety standards present a challenge, and what is the particular area, maybe we can start with one of them, Neil, that you'd like to talk about, that people struggle with to comply with.
Yeah, exactly. And I think coverage is probably the biggest area of pain. Achieving many of the functional safety standards require 100% MCDC coverage, for example. Right. If you're developing an ASIL D application for the automotive sector, or even ASIL B requires 100% branch coverage. And Andre, you and I have bounced a few ideas around in the past, but we all agree, I think, that everyone underestimates how long it takes to get that 100%. In my experience, some people go top down and try to drive coverage from system tests. Others start at the unit level with unit tests and try to get coverage that way. And you've probably seen this, I guess, in your customer base as well. Have you seen customers adopt toolings or strategies to combine coverage, or have people struggled with that issue to get the final coverage up to 100% from different testing levels, maybe?
Yeah. Actually, as a matter of fact, code coverage has become in recent, I would say in recent, like several years, is becoming a huge emphasis in our automotive customers. And one of them, and everybody wants to show compliance with the standard, basically show, let's say 100% of some metric, right? Statement or branch or MCDC. And then how do you do that? And the easiest answer that people find is, oh, we're gonna just do it with unit testing. And sometimes unit testing, like a lot of times unit testing is a great approach, but then I'm gonna show you some things, Neil, then since you asked the question. And so what I'm showing right now is the tool, which is called CC++ Test. It's a tool from Parasoft. If you wanna learn more, you can go and on our website and request a demo or watch some videos. So you can learn about Parasoft with just browsing our website, I'm sure. So I'm not going to go into details describing what the tool does and what the tool doesn't. I'll just talk about the code coverage aspect. So where a lot of people just start with that requirement and say, okay, why don't we do unit testing? But then unit testing is an expensive process. So one approach, I mean, there's many approaches, but one approach is to run your existing testing that you have today, the integration of system level test, and see how much coverage you already have, and maybe look at unit testing practice as the way to fill the gaps in coverage, right?
Sounds good, because it's hard to drive the code through through certain paths at system level, isn't it? It's hard to do error detection and error forcing in the application
exactly
level. Yes.
So I just have it just to demonstrate the point. And again, that's just one of the approaches, right, Neil? So unit testing is a good practice and people should not short circuit it. But when we're after compliance, when we're after filling out the requirements for the code coverage, that's one of the things we can do. So what I have here is an example, right? I have a timer project and I ran some tests here. So I'll show you the test. So I ran some tests, I've generated coverage logs. So let's just call them a manual system level test for all practical purposes. And then I can load that coverage here in my IDE, right? Or I can generate reports. So I loaded the coverage. Again, no unit tests have been created so far, but this coverage from my manual testing exposes what you just said, Neil, is the error. There are some error conditions that are really hard to simulate at the system or integration test level. So we need to accompany that with some unit tests. So I also have a unit test here created. You can with Parasoft technology, you can auto-generate unit tests or can manually create them. So I created one unit test, just one. I didn't spend much time on it. And I've created a stub, right, that will inject that error condition. And let me run that unit test now and then see what will happen. So run unit test.
That's the value of unit testing, isn't it? That you can stub, you can simulate those difficult to test conditions. And I think then combining with application level coverage makes sense.
To get where you want to go, right? So now, look, I just covered that line. And I've shown you for the demonstration purposes, I only focused on line coverage, but Parasoft, as you said, right, there are other coverage types required. So we support MCDC, branch coverage, statement coverage, all the required coverage types for the safety critical standards.
That's awesome, Andre. Yeah, and that brings me on to another bottleneck, really, as well as coverage, which is the dynamic testing that a lot of our customers struggle with. Getting that 100% certainly seems to be an easier method that you've just presented there, and I'm certain that can help some people on this webinar. But a lot of customers also struggle with coding standards compliance. For example, again, to use automotive, MISRA and AutoSAR coding standards need to be followed. There's hundreds of rules, literally, to comply with and to follow. And sometimes our customers don't get the feedback quickly enough for whether their code is compliant or not. So they check the code into GitLab, for example. Then there's loads of processes that they then follow. Then they might get notifications, maybe sometimes even a few days later, that there's some violations that have been found. Have you got, and developers don't have time to wait, really. That's one of the pain points that we're aware of. Do you have any solutions there, perhaps, that could help this obstacle?
Right. So let me reiterate your question so I fully understand it. The idea there is that developers want to run faster, right? And there are way too many rules in MISRA or ATASA or CERT-C standard that that takes just a lot of time to run, right? And they produce a lot of violations. So yeah, so yes, our customers and we're helping our customers going through that kind of transition from doing absolutely nothing, and I'm going to show some things while I'm talking, from doing absolutely nothing to something that is tangible and developers can run faster. So one, again, those are not like the by the book approaches. We're more showing you, highlighting the practical applications. So by the book, you should run all the rules all the time on developers' desktop and the CI/CD automation. And the life should be rosy, but you'll know, right? The life is not rosy, right? When developers start to actually touch static analysis tooling, they quickly get frustrated and annoyed by the speed and number of just violations and noise that supposedly noise that those safety standards require them to comply with, right? So what can we do? What can we do? So there's one little thing that customers are using, right? It's so for example, what you can theoretically do here is that you can create a rule set that will not include, so for example, our MISRA rule set has 354 rules. So you can, MISRA C 2012, right? You can go in and select which ones you want to comply with. And you can select just required, right? And then look at the rules and say, okay, we're only going to comply with required, and then save it as particular rule configuration, right? Also, you can adjust the scope. Maybe you want to test only on files modified in certain branch or modified after since cutoff date. It's a very practical approach. So there are ways.
Important, yeah.
Right.
Yeah, sorry to interrupt that, Andre, but yeah, that's exactly the problem that a lot of customers have had is they change something, they don't want to run the analysis on the whole project because the whole project maybe takes several hours to build. So the fact that you can do an incremental analysis there is the right strategy, I think. Just test what's changed and do a change-based testing approach.
Yeah, so a lot of like the VS Code editors, the one I'm showing you right now, is becoming very, very popular, And we have a plugin for VS Code. I'm just gonna tell you that if you go to extension and search and type MISRA here, you will see that Parasoft extension comes up, and then you can download it and use it. Right, that's the only extension that's coming up. But we also have. So what is running right now is analysis on the dev rules properties file that contains just a subset of rules to run on the developer's desktop, right? And the remaining of the rules will be run, let's say, on a more beefy, more powerful build server, right? So I'm running just on the files that were modified. If you used Parasoft in the past, you know that our standard edition has a configuration file where just what I was showing you with Eclipse configuration, we can also just set up there via settings there, and that just works on files that are modified locally. So locally, I have only timer modified, and look, I'm not displaying all of the results for all of the files. It's just a subset of results on subset of files, okay? And then in addition to that, if I'm running, let's say within GitHub, and I have some results there in the GitHub. So when I run within the GitHub pipeline, and you'll be showing GitLab, which is similar, I have my violations also displayed here. So the idea is that how we can run faster, like why are we talking about this? How can we run faster? Divide and conquer. Maybe developers on the desktop have to run only on locally modified files, and there's specific configurations that you have to set up. And also in the context of their pull requests. So when you're reviewing the results of a pull request, right, in GitHub, then you can also look at the violations there. Or another thing you can do, which is really fast, is downloading, not even going to the GitHub, but downloading the results directly into the IDE. So right? that complements what I just did. So there are more interesting things here. Record is checked for null after dereferencing. So there is a more in-depth analysis that is happening there on a server, right? That I'm not paying my time as a developer to do. So just a couple of approaches, right, Neil? Run locally,
Definitely.
divide and conquer the rules, and then adjust to the developer's workflow and have it there ready in the IDE. Okay.
I think that's going to really help developers to do that local analysis. Often developers are only interested in the context of their own particular files, their own change set that they're working on, their own feature in their feature branch. But then to have the ability to pull in the server analysis to get those defects which occur at integration level and require all of the files in the link. A great way of going faster with compliance, definitely. Yeah.
But you know what the problem? Like, there's one problem here, Neil. That static analysis runs on the top of build process. That we're and many times the build process is already long enough. So we talk to customers and prospects, and we always ask, how long does your build take? And you know the number one answer is too long.
Right.
Nobody likes like the entire build, and there's always this person who runs the builds, and the challenge there is the expertise to understand what the big build, the main build is doing, what are the dependencies, and how to make it run faster, so that tooling that are sitting on the top or like running after the build, like static analysis, unit testing, are not too much, strain on the developer. Nobody likes to wait. Have you heard that issue in your day-to-day job when you're doing consulting for companies?
Oh, most definitely. And the problem's getting worse as well, because software complexity is increasing, it's not decreasing. And if you think about typical software projects, they're pulling in dependencies from, you've just shown GitHub or GitLab. These open source repositories are pulled in, which require software to be built from source code, extra libraries. The numbers of lines of code in cars and medical devices is almost growing exponentially. So this problem is getting worse, the problem of the software build. So there's three problems really. There's the build itself, as you say, taking a long time. There's the build and people not knowing what's in the software build and requiring an SBOM, a software bill of materials, to produce a forensic view of what's actually inside the software build, because people have lost track of the dependencies now. And then there's the problem of people maybe experiencing brittle builds or builds that fail as they go along. The software build is too brittle because of dependencies, or it's an unreliable and unstable build. And actually, I can show you some solutions to that that build
cool.
on the
Let me make a
PowerSoft
presenter
data.
then. Yeah, I just made you a presenter, Neil. I'd like to see it, because I've been showing our tooling. It may be right about time for you to show what you got. What are the practical approaches to accelerate the build, for example?
Yeah, awesome. So this is a kind of small example, and the benefit is if you've done an analysis of your code base with PowerSoft, then you can get this architectural perspective straight away, because we have an integration.
Are you showing LaTeX? Because we're seeing the
I'm showing this intended architecture diagram.
Oh, okay. So you're here. Perfect.
Okay. So this is kind of an example of an application which has an architecture with different layers inside it, and there's some design intent communicated. These gray modules should be optional. Now, if there are optional modules, that implies we can build them independently. And these colored modules here are mandatory. So the first thing we can do is take a code base that's been analyzed with PowerSoft C++ test and visualize it in a dependency structure matrix using LaTeX. And that's what you see here. Can you see my screen okay, Andre?
Yes, now I can see it well.
Okay.
What am I looking at?
And probably best just to compare side by side. This was the architecture picture. We can visualize now using the PowerSoft data. This is just loaded into LaTeX directly. And you can compare the architecture as it is with the intended architecture. And you see COM is indeed sat at the top of the architecture here. And the scheduler, hardware abstraction, and drivers, the intention should be, for example, that hardware and drivers don't use the communication layer, because that would be a violation of the architecture. You can see things in the code that are not in the architecture, things like utils. And what lattice does, the way we read a DSM, is we read down the column to see what a component is using. So we can see COM is using driver with a strength of 1,259. And we read across the row to see what a component is used by. So HAL, for example, is used by scheduler 93 times, this component here. And straight away, we can actually take this design intent and put it into rules. So if we've said that these parts of our system should be independent, we can create independent subsystem rules here. And this will help with the build later on, because if we want to build these components fast and test them fast independently, then we need to preserve that independence. Otherwise, we introduce a coupling into the architecture. And you can see already. Oh,
yeah, how would, so I'm going to ask a naive question for everybody's benefit. How would decoupling a set of C or C++ files, basically source files, dependency-wise, will accelerate the build?
Right, that's a great question. If you look at this component, which is the network management part here, this core component here, you can see that it's used by lots of things. All of these things it's used by above it, but it's also using all of these things below it and all of these things above it. So that means in order to build it, we have to build its dependencies as well. So we're not just building this component, we're building all of these other things that it uses as well in order to get it functionally compiled into binaries that we can then use. And that's really the problem of transitivity and dependencies and coupling in a complex build system. You have these change propagators that have a high impact of change. There's a high cost of changing this component. It has a huge impact, and Lattice can measure that cost of impact with an impact analysis. But it's also really easy now to clearly see which parts are decoupled through these rules. And then those could be candidates for parallelizing the build. So this is kind of a screenshot of a parallelized build in GitLab, where this approach was used. Instead of a sequential build, we can now build things in parallel because we see which elements are decoupled. And the same for testing. We now see from this architecture that task controller and proprietary messages are independent of each other. They could be tested by independent testing teams, for example, organizationally and through the code. So that's kind of one of the benefits of looking at architecture, and also priorities. You see that util here is heavily used. So maybe if our strategy is to do bottom-up unit testing that you're talking about, let's begin with the most commonly used components that are really foundational in our architecture. Does that make sense?
It does make sense. You've used the word architecture a lot over the past 5 minutes, right? And I know that when we start talking with customers who want to be compliant, let's just say with ISO 26262 or 61508 or any other like safety standards for automotive or medical or industrial, they ask us for code coverage tooling, for unit testing, streamlining unit testing, maybe requirements traceability. But there are also clauses in those standards that talk about architecture verification. And most people do it manually, and that's also puts a strain on development and the speed, right? Because the manual steps to evaluate and to validate the architecture to be compliant with those standards is just hard. But what you're talking about here, can we use this approach there to maybe automate some of the checks? Or I don't know, like you can
probably... Indeed we can. And I'm just popping up table 3 from the ISO 26262 standard. And this has specific tenets or principles for software
architecture. That's the table.
Yeah, and it's interesting, isn't it? Because the same standard has requirements for MCDC coverage, for example. So we're talking about the same activities for compliance that PowerSoft and Lattice offers together. So this is why the integration makes so much sense, is because to comply with these, you need different tools and different features of the tools to, for example, demonstrate appropriate hierarchical structure. That's exactly the DSM. But also, how do you demonstrate cohesion, loose coupling between components? Again, from the DSM, we can see which parts are highly coupled, which parts are loosely coupled. And we can actually drive this from metrics. We offer all the metrics that you just mentioned in the part 6 of the standards, such as connectedness, coupling, cohesion, and we've worked with people like the TÜV certification authorities in Germany to define good values, bad values for cohesion and coupling and stability. What is a good metric for those for compliance perspectives? And many customers drive their certification efforts through metrics like these. And you can actually use the tool to improve. So if you see something like a low-level component using a higher level component here, this is a bad architectural decision, because it creates a coupling, it creates this dependency. You know, the tool will give you hints for removing dependencies, and so if you actually take those hints, you'll watch this number 1 here. You'll see that with this change, we actually managed to decouple driver from the highest part of the communication level, and so that drives the efforts towards increased modularity, improved decoupling. If you have a microservices architecture, for example, then this is the way to remove these dependencies above the diagonal, where you have lower elements calling higher elements. And then, you know, setting those subsystem rules, setting those layering rules as well to enforce that architecture, so that I don't want to make the situation worse if I have coupling. And that's something that I could talk about next, Andre, if you like, with putting this, once you have these rules, putting them into compliance in GitHub or GitLab.
Right, because I've used Lattice before I joined Parasoft. You know that, right?
Yeah.
And then we used it for refactoring. But the idea here is that the second somebody changes the code, the architecture diagrams could potentially change. So what we struggle with is that we would have to go back and update all of those diagrams manually when the change is made, or we have to have a discipline of first updating the diagrams manually and then going and changing the code and making sure that we're not introducing additional, let's say, clutterness, dependencies, or technical debt, right? But then we were never able to check it without scripting kind of on the fly. Is that what you're talking about here, creating architectural rules?
It is, yeah, creating architectural rules so that we minimize the cost of change. And I just, while you were talking there, marked a component that's changed, and we can actually calculate the impact of that change rippling through the system. So this is what's exciting, Andre, because now we know the cost of each change, for example, in a branch. We can then do a much smarter based approach to our testing. We could actually say, well, instead of blindly testing everything again, well, let's just test the impact of the changes. And so it's much more, it leads to faster outcomes and faster pipelines. So if I put this into everything we've been talking about could be put into a DevOps pipeline, as you said. We could do the build, and as you say, everything depends on the build. We can improve the build, we also improve testing and static analysis and dynamic testing and all of the activities that we use to do the build. But then the exciting thing is this real pain point of functional safety is the documentation. It's writing the documentation to show the TÜV certification authority or similar that we've done these compliance activities. And I used to have to write these by hand a lot, these reports for Part 6. Now it's on autopilot, and we pull the data from Parasoft, from Lattice, from the build, directly in a DocOps stage, so like an automated documentation stage, and then we map to the clauses of the functional safety standard. And I'd love to demonstrate that to you if I could.
Yeah, and so what we're looking here is that we've talked about those fundamentals today, the build, how we can accelerate the build by just understanding the files that can be built together. Then the Parasoft, I've done a quick demo, right? So we can get back to it later. Architectural analysis, so and the docs. Well, those 4 things. Let's get into the demo. I just want to highlight that we've touched on those 4 pillars during the conversation today already.
Yeah. Exactly. Yeah. So let's take one of the rules that we said. We said utils can't use the communication layer, which is a reasonable architectural decision here. What happens then if I come along as a developer and I'm working in the utils function and I create that by dependency? Maybe also I'll add a function, Andre, with some MISRA violations and no tests, for example, and we'll see what happens with coverage. We can just see whether these changes are good and whether my bad behavior is actually captured. So inside the actual source code for util functs, I know I have some unit tests which pass. So I'm going to break some unit tests just by changing the functionality here and reversing a decision so we can see the effect of those changes. I'm also going to create that add dependency to the comp layer through a hash include, and I'm going to introduce a new function here, which is full of AutoZAR and MISRA violations and also has no tests. So it's a bad change that I'm making. You know, previously when I worked on safety projects, this kind of bad behavior wouldn't be discovered until much later, maybe even just before the release of the software. But now, because I've put it into a pipeline, I can create a merge request here. So I can say demo webinar as a new branch, for example, start a new merge request, and the pipeline takes care of everything for me. I don't even need to know the details of Lattice or Parasoft. I can create that merge request, and then both tools are running on very modern DevOps infrastructure. So you can see the pipeline's just been kicked off here. The build is first of all going to do the static analysis. We're using here Kubernetes on a GitLab runner with a Terraform infrastructure with dynamic scaling so that the pods are only used when the pipeline kicks off. So we've got a very efficient DevOps pipeline, and if any of our customers needed or anybody on this call needed some help with creating this DevOps infrastructure, containerized environments for Parasoft and Lattice to do testing and architecture compliance, we have all of that waiting. So this pipeline will kick off, and just to save a little bit of time, I'll show you the.
I do have a question. While it's working, and before you show something, it's not a question; it's a comment, right? You said that it will be that problem will be caught maybe potentially later. Well, that problem could be caught in a code review, but then the code review is also manual. So we've talked about trying to eliminate everything possible that could be automated and put it in a pipeline, and just giving the developers focus to do code review only on the things that the tools couldn't check and verify, like coding standards, architectural rules, right? So they should be focusing on the right stuff, like the actual algorithms and structure of the code, and maybe looking at the how requirements have been properly implemented or not.
Exactly, and this just takes the strain of all of that, as you say, Andre, because now in my merge request, the bulk of the work, the code review data, has actually been put into the merge request. We also have the Lattice dependency information put into the merge request. So everything is available in one view. I see my architecture, I see the good and bad of the architecture. I see the delta, so what's changed. You can see this bad dependency I introduced from util funcs is now showing up as a violation of the architecture, so I can see what's changed. And then this heat map where we pull the data from the AutoZAR MISRA violations that you showed in C++ test. I also enabled the certificate, the cert standard checkers for the security checks that you offered as well. And now for the first time I can see through the prism of the architecture where I'm good, the green stuff, where I'm kind of making progress, the orange and yellow stuff, and where I'm really, really bad from my compliance perspective. And you can see I've made the function that I changed really bad here, plus my impact. So I can assess, before I merge this code now, I can assess the impact of my changes. Plus I get the new violations from Parasoft here. I can actually click to the line of code and see that the function I added has MISRA and AutoZAR violations, which is not good. And so I can actually make an easy decision. I could automate this decision as well and say we're not going to merge this because of the test failures, the software quality failures. This is not a good code to merge in. And I could write to to my colleagues here, for example, and say please change, fix errors, and then that would then be in the Git workflow. And then all of these issues would have to be addressed before my code is merged. And that's why, going back to your first comment, Andre, about doing this at speed, I get the feedback so much more quickly now when I make changes.
That is definitely going to speed up a few things. Checks for architecture, checks for code quality, checks for coding standards, and verifying that you have the right coverage, enough coverage, and visualizing it. But what about the documentation piece you were talking about? Can we accelerate that?
Yeah, and that just pops out of the so with the pipeline that we have. So we have a GitOps oriented pipeline. We have different stages in the YAML, which pulls containers for PowerSoft, and Lattice automates the analysis work. And then we have this DocOps stage, which then produces the required documentation. And this is all enabled in that DevOps pipeline. So that this artifact that you see here could be socialized with every build or with every release candidate, for example. We show you which clauses we've addressed from the functional safety standards, which clauses we just pulled out of those tables, and then the data from both tools verified based on the PowerSoft rule here and the AutoZAL rules, and then we include the DSM as well and the coverage reports, all in one report that can then be socialized. There's even one customer we're working with where this is connected to the JFrog Artifactory instance that then publishes directly to TÜV's, the TÜV's portal. So they really are extremely automated. They're automating even the delivery of the certification artifacts to the certification authority. And that puts certification in, instead of just a one-time process, it's a continuous compliance process. And then the TÜV just need to look at the changes. They can see all the artifacts. It's taken so much of the certification effort out of the picture and put it onto automation.
Wow.
Yeah.
That is. I know for a fact that companies that we talk with, that alone saves weeks. Like what you just shown, it's easily 2 weeks of, I would say, a development team, right? Like producing all of the documentation. It's code freeze, and everybody's either going on vacations, who is lucky, or getting stuck creating those documents. And at that point, developers are not productive. They're sitting writing documentation where we could automate it, right? Yeah,
it's so true. And what I like about this is that it takes the strain for you, not just of the build. This build can be optimized because of the architectural data. You know, we see the pipeline running, we see the build step, we see the static analysis step, everything just going on that. I'm sorry about the rain. You can probably hear a lot of water in the background. There's a raining behind me. But this is just this is now just instrumenting, running all of those checks, coverage, static analysis, architecture, completely automated on this DevOps infrastructure. And I think to come back to Lattice, you can define your model, looking at the impact of changes. You can use the tool to load any PowerSoft data. Actually, what I need to do here is create the embedded profile and just load the DEPS files. So whatever my DEPS files from PowerSoft are here, I just add them in and create my new analysis. So it's as simple as that to get this visualization. Create the project, and then Lattice reads directly from the PowerSoft data through the integration. So it's very fast.
That is very fast and valuable, because the value of that, I think, is that the second they change the code or somebody changes the code, PowerSoft static analysis scans it, produces you the dependency data and all of the symbolic execution data, and so not symbolic execution, but all of the symbols from the code, and then right there, so you build it, you get the refreshment, so you don't need to go and update your diagrams manually. That, to me, that's a little.
You don't, and actually you can define new architecture. So one thing we're doing a lot at the moment is safety architecture, where people are saying, well, how does, for mixed criticality systems, I'm developing ASIL B, but I need to know the interactions with the rest of my ASIL. I can now view that in a CAD diagram, or for the first time define my safety architecture and look at, for example, the control flow between ASIL A and ASIL B, and actually analyze the control flow and data flow from a safety perspective as well. So if anybody out there is using PowerSoft already for analysis, safety analysis, you can now do an ASIL analysis as well, and look at your data through the prism of the safety architecture too.
Right, yeah, and that would save people a lot of time and money, because for ACLB you have to perform some activities that you don't have to perform for ACLD, and not vice versa, but right. So it's cheaper, right, to develop ACLB software because you don't have to, let's say, collect MCDC, for example.
That's right. You don't need decision coverage for this, but for for ASIL A, you would need statement coverage. For ASIL D, you would need MCDC. So you can prioritize based on the.
So number of test cases, unit tests that you have to create for ASIL D is different. So you're saving just on the testing time alone. Huge number of hours and weeks potentially.
Yeah.
Okay. Yeah. I think we're ready to wrap up. It's been 40 minutes of exciting discussions and demonstration. Do you have anything else that you want to quickly present before we go to our questions that are already popping up here?
I think it would be great to go to the questions. Yeah.
Okay. If you guys have any questions, please start typing them. I have, I think, 1 or 2 there already. So let me open the questions view. Okay, how do you? Okay, so I'm not very proficient here with this. So okay, good. So the first question is, our embedded software testing cannot be easily automated because it's tied to a board. I'm presuming like a target board or something. What do people do in that situation? How to automate? So the question is this: the customers are probably running some sort of a dynamic testing, embedded testing. Maybe it's a unit testing, maybe it's a system or integration level testing that is being executed on the board. So it's a hardware in a loop type of testing, and then they are I guess there's a problem, right, to connect it to a CI/CD build, like Neil was showing. His build runs somewhere in the cloud. It's hard to connect it to a board. So yeah, that's a great question. There are a couple of approaches that we recommend. First of all, run your unit testing on a simulation instead of a real board. There are many simulators available. And since unit testing isolates the software from a lot of hardware interaction, and simulators are very appropriate technology to be used for example, unit testing and potentially even integration testing. So that's one approach people use. Another approach that we have seen, and Parasoft provides an automation to run on target. So we can script out the way we can help with automating creation of a harness, creation of test cases, auto-generate test cases, and creating all of that, the cross-compiling that, building that as a test executable, and then sending that to the board via maybe debugger API or some sort of SSH connection. A long story short, we've got the expertise to automate it. Yes, it's difficult. It's a difficult question, right? But there are approaches that we can apply here.
Yeah, and we've also done that for several customers. Common runtime environments like Wind River Workbench or Green Hills or Tasking. We've put wraparound scripts that do actually connect to a target from a physical machine that's in a lab, and run tests and get feedback off the target, or as you say, using simulators. So we'd be happy to follow that question up with more details afterwards.
Yep. So hopefully we answered that question. So the second question is, our code base is very old. Well, I can relate to that. We need to refactor, but I still don't understand how matrix, which was presented, will help us in any way. I think that's a question to you, Neil. Maybe you can go back to DSM. By the way, what does DSM stand for?
Yeah, I should have said, sorry. Dependency structure matrix, or design structure matrix.
So maybe you can take that question.
Yeah, it's a great question. So what a DSM does is it reveals the big picture of the structure of your application. So you see which parts of the system are interacting with which other parts. And that then helps you to work out which parts could be built independently, could be modularized, and which parts that are coupled together, which would need each other in the dependency chain. So whenever you have a coupling, like scheduler is using driver with a strength of 176, driver is using scheduler with a strength of 1. So at the moment, we need to build these two parts of the subsystems together to be able for them to use each other. Because if you just built scheduler, you'd miss these dependencies. If you just built driver, you'd also need this dependency from scheduler. And what Lattice gives you is the ability to see exactly what that usage is, and then consider moving, for example, this dependency down into driver, or refactoring so that it doesn't use this component at all. And when you start working like that, you're talking about decoupling, you're talking about improving the independence of different parts of your software, reducing the complexity, reducing the cognitive complexity. That all helps with accelerating the build, because the fewer dependencies that you have, the more isolated your components are from each other, the more decoupled they are, the easier it is to build and test those components. And conversely, when you have high degrees of coupling, such as we saw in COM, this makes maintenance a nightmare. And this is kind of typical spaghetti code, really.
Yeah, seen that before. Okay, I guess that was a good question. I didn't realize that Lattice can do that actually. That you can help you refactor faster. That's cool. All right, I'm going to wrap up. Thank you, Neil, for answering that question. I'm going to wrap up, and then there's no more.
Sorry to interrupt. I see another question just came in actually from Mr. Fabian. Will the VS Code plugin support for the professional C++ test be supported as well?
Will the VS Code plugin will be, well, today VS Code can support static analysis and code coverage, right? So Professional Edition is Eclipse based, and VS supports Visual Studio. So I guess let's follow up on that question, and I'd like to understand the context, because
and there's a smiley there also, and why isn't it there? So this is a known fact.
Yeah. So VS Code is a very lightweight IDE, and then we are adding features there that are highly desirable by customers. Like, for example, static analysis. Everybody wants to use it in the context of developers IDE, right, or Visual Studio Code. So we've added that. Code coverage is right now, I would say, one of the hot topics there, especially in the automotive industry. Everybody wants to be compliant with standards, and hence the code coverage is currently very, very desirable feature to have, and that's been added to VS Code. As we move along, I'm not a product manager, but I can tell that we will be adding more and more capabilities to our command line utilities, and to support various unit testing frameworks, and to add them to VS Code. So I don't know if I answered the question there, but we are adding capabilities to VS Code as we see demand from the market.
Thank you.
And I like the smiling. I'm also smiling. So, okay. So let's just wrap up. Do you see my screen? I should be displaying it, right? Right.
Yes.
Chantal, can you confirm?
Yes.
All right. Because Neil and I were going back and forth. I wasn't sure if. All right, so just to wrap up, what Neil's shown you in a GitLab pipeline, we believe it's a good way to streamline not only static analysis and unit testing, but also bring now the architecture verification and produce reports, to compliance reports in every single build. So there are a lot of text here, bullet points. I'm not going to read it. Today, I hope that you had a glimpse of practical techniques that people use in reality. We wanted to not to be a dry webinar where we would tell you the book definitions of what you should do. That was not the intent. The intent was just to give you a couple of hints and tricks and capabilities, highlight the capabilities inside our solutions, Lattice and C++ test, that will help you streamline your compliance testing. Okay, and that's it. If you have further questions, our emails are here on the screen. If you'd like to request a demo or an evaluation, please follow that link. It's a guided evaluation. We can follow up on all of the requests. So we will follow up on all requests. Okay. All right. I think we're up against our time for the webinar.
You are. That's a wrap.
Yeah. So with that, thank you everybody for spending some time with us today. Thank you, Neil, for being my co-host today.
Thank you, Andre. Thank you, everyone.
And
Thank you, Andre. Thank you,
we'll,
Neil.
we'll see everybody soon.
I will close the session now. Thank you both.
Okay.
And
Mhm.
everyone.
Bye-bye.
Bye, everybody.